The ground beneath us isn't stable. It only pretends to be calm. Beneath your feet, tension builds silently. Invisible forces grind against each other. The planet is constantly shifting. And lately, something feels different. Earthquakes seem stronger than before, buildings fall faster than expected, cities tremble longer than remembered. People ask the same question. Are earthquakes actually getting stronger? Or are we just noticing more? The answer isn't simple, but it is deeply unsettling. Earth's crust is broken plates. These plates never truly rest. They slide, collide, and separate. Sometimes they lock together tightly. Pressure builds for decades underground. Stress accumulates silently over years. Rocks bend like compressed springs. Eventually, the pressure overwhelms friction. Energy releases in violent bursts. The ground shakes without warning. That sudden release is earthquake, measured in magnitude and intensity. Scientists track them worldwide daily. Some regions shake more frequently. Others remain quiet for centuries. But patterns are slowly changing. Megacities now sit over fault lines. Urban growth increases visible destruction. Stronger buildings still face massive stress. Population density amplifies perceived impact. Media coverage spreads fear instantly. Social networks broadcast every tremor. But perception differs from reality. Are quakes truly increasing strength, or are measurements more precise? Modern sensors detect smaller movements. Data collection is faster now. Global monitoring never sleeps anymore. Yet massive quakes still surprise experts. Something deeper may be shifting. And the real reason shocks many. Earth's plates move centimeters yearly. That sounds harmless and insignificant. But over decades, pressure multiplies. Tectonic plates lock along faults. Friction traps enormous stored energy. The longer they lock, worse release. Some faults stayed quiet centuries. Silence often hides rising danger. When rupture finally happens, devastation follows. Stronger earthquakes usually mean longer locks. Scientists study stress accumulation carefully. They analyze historical seismic records. Certain regions show repeating cycles. Others behave unpredictably and chaotically. Climate change may influence seismic stress. Melting glaciers reduce surface pressure. Less weight allows crust rebounding. That rebound can trigger fault movement. Water reservoirs also shift pressure. Massive dams add tremendous weight. Underground injection alters rock stability. Human activity sometimes awakens faults. Mining blasts weaken structural balance. Deep drilling changes underground tension. Even wastewater disposal affects tremors. Induced quakes increase in some regions, yet natural forces remain dominant. Subduction zones create mega earthquakes. Plates dive beneath neighboring plates. Stress builds along gigantic boundaries. When released, energy becomes catastrophic. Ocean floors suddenly jerk upward. Tsunamis race across entire oceans. Coastal cities face unimaginable destruction. Instrument precision reveals deeper ruptures. We now measure extreme magnitudes accurately. Past centuries lacked sensitive instruments. Some older quakes were underestimated. Today's numbers appear dramatically larger. But Earth's power hasn't changed suddenly. What changed is our awareness. Still, risk is undeniably rising. Urban expansion increases vulnerability everywhere. More infrastructure stands directly above faults. The stakes grow higher each decade. The strongest quakes strike suddenly. No siren warns beforehand. No countdown prepares the city. 1 second changes everything forever. Roads split like cracked glass. Bridges twist under violent force. Skyscrapers sway beyond safe limits. Power grids collapse instantly. Hospitals face overwhelming emergencies. Aftershocks continue the nightmare. Fear spreads faster than tremors. Communities struggle to recover stability. But why do some intensify? Fault length determines potential magnitude. Longer faults store greater energy. Deeper ruptures release massive force. Subduction zones produce giant earthquakes. The Pacific Ring remains active. Countries around it stay alert. Stress transfers between nearby faults. One quake can trigger another. Chain reactions increase regional danger. Scientists call this stress redistribution. It complicates future predictions greatly. Earth doesn't follow human schedules. It follows pressure and physics. Some regions approach critical thresholds. Locked segments are nearing rupture. Instruments detect subtle ground deformation. Satellites measure crust movement precisely. GPS reveals millimeter-scale shifts. Technology exposes hidden geological tension, yet prediction remains frustratingly limited. We forecast probability, not timing. Preparation becomes humanity's only defense. Stronger building codes save lives. Early warning systems buy seconds. Those seconds mean survival chances. But densely packed cities worry experts. Infrastructure ages faster than expected. Retrofitting costs billions globally. Developing nations face higher risks. Poverty magnifies seismic devastation. So strength feels increasingly destructive, and the future holds uncertainties. So what must change now? Policy determines future survival rates. Strong science must guide leadership. Governments cannot ignore seismic data. Risk maps must shape zoning laws. Construction standards require strict enforcement. Outdated buildings demand urgent retrofitting. Hospitals need reinforced foundations immediately. Schools must meet seismic safety codes. Public transport requires structural evaluation. Critical bridges deserve constant inspection. Early warning systems need expansion. Rural regions require equal protection. Funding must prioritize disaster resilience. Insurance policies should reflect true risk. Urban planners must avoid fault zones. Coastal cities require tsunami preparation. Evacuation routes must remain accessible. Drills should become routine practice. Communities must know emergency protocols. Education builds calm under pressure. Awareness reduces chaos during crises. Transparent communication prevents misinformation spread. Media should promote preparedness responsibly. Data sharing strengthens international cooperation. Seismic research deserves larger budgets. Technology investment improves early detection. Satellites and sensors need upgrades. Building materials must evolve continuously. Engineers should innovate shock absorption systems. Private sector must share responsibility. Corporations should audit infrastructure risks. Emergency funds must remain accessible. Rapid response teams need training. Local leadership matters most initially. Strong policies save countless lives. Weak enforcement multiplies disaster damage. Prepared cities recover far faster. Resilience must become national priority. Because earthquakes will not wait. Pressure continues building underground silently. The next rupture is inevitable, but devastation is not inevitable. Smart policy transforms vulnerability into strength. The choice belongs to us.